So as we get ready to talk about the algebraic properties of limits, let's take a look at well-behaved functions. And if you take a look at a lot of the functions we've looked at in the past couple of lessons, they are very much not well-behaved. We've had some weird piecewise functions or some weird oscillating functions. We've tried to just kind of throw every weird thing we can. So let's just go back and look at a very, very normal function. Let's consider the function f of x equals x squared minus 2x. And not a lot of weird things are happening. It's a parabola. It's going to be a quadratic function. If you just want to kind of quickly be able to graph this, you can factor out an x, and so you get x times x minus 2. So the zeros of this function are going to be at 0 and 2. That tells us kind of intuitively that the vertex is going to occur at x equals 1, and if I substitute 1 into the function, I get 1 minus 2. So the vertex is going to be at 1, negative 1, and so I get a function that's a parabola. Nothing weird, nothing strange is happening to it, just a parabola that looks like that, f of x. So if I wanted to say something about the limits of a particular value of this function, so let's take a look and say, what is the limit as x approaches 3 of f of x? Well, if I come out here, and I can even go a little bit further here and extend this out and have an idea, because this function doesn't do anything weird, as x approaches 3, I'm just going to go through whatever value of 3 is. And so it's going to work out because nothing strange happens, that for this particular function, the limit as x approaches 3 of f of x is going to equal f of 3. And so right there is my f of 3. And that's going to be whatever the limit as x approaches 3 is going to be approaching this particular function value. So it would be really nice if I could build a system where, as long as the function's well behaved, if I want to evaluate this, all I have to really do is look at f of 3, which would be a very easy value to get because I could just plug it into the function. In fact, this is a true statement for this particular function. And so what the following properties are going to do? The following properties will allow us to justify using the idea of direct substitution for well-behaved functions. And well-behaved just means that nothing strange happens. It's a continuous function, and things are going very normal. So rather than do what we've been doing, which is like build a table of all the values around 3 or anything like that, it's going to be really nice if we can build the mechanism that allows us to evaluate this limit as x approaches 3 by simply plugging 3 into the function and getting a value. And these following properties are going to allow us to do just that. And it makes evaluating limits analytically very easy once we understand how these work.